Okay, this is the second lecture on 4.5, and we finished with this graph and the previous one, and we're gonna go back to this graph quite a bit, but for now let's go over a couple properties of the graph, or characteristics. Of the graph of y equals sine of x. Okay, so we're gonna start with domain. Right, so domain, you need to think, well, are there any restrictions, right, on the x's that you would put into in place of x, right, and y equals sine of x. So the graph just keeps going to the right, to the left, right? So the domain is all real numbers, or we can write from negative infinity to positive infinity. Okay, the second is range. So range, we're looking at the y-axis, so how far the graph stretches along the y-axis. So you can see it goes from -1 to +1, right? But that comes from the fact that when you have your right triangle, okay, so remember that sine was the length of this over the length of this, right? So when we have a right triangle, so the length of this cannot ever be bigger, greater than the length of the hypotenuse. Okay, so therefore the value of sine cannot be bigger than 1. Alright, so the range is from -1 to 1. And the period, important thing. Period is basically the length after which the graph repeats. Right, so I can look at, for example, let's look at this, the highest point, or the maximum, to the highest point, right? So I go from here to there. So I can see that it stretches from, or maybe let's look at, it's not that easy to see, right, that it's 2 pi. Anyway, if I look at this point and this point, right, after 2 pi the graph repeats, right? So I'm again on an uphill motion here after 2 pi, right? Just like I was here, right? So this is my period, and the period is 2 pi. So 2 pi. What's next? Symmetry. Alright. The graph is symmetrical. If you look at it like this, right, it's hard to see that symmetry. But if I just sketch a part of it like this, okay, I hope you guys can see that it's symmetrical with respect to the origin, right? So this point has a corresponding point over here. Okay. So algebraically, what that means is that f of, or negative f of x, you can write it a couple of different ways, is the same as f of negative x. Okay, so in terms of sine, it's going to be sine of x, or negative sine of x, will be the same as sine of negative x. If you don't believe me, you can check it. So sine of pi over 6 should be the same as sine of negative pi over 6. Okay, so this will be sine of pi over 6 is 1 over 2 with a negative, so negative 1 over 2. And here I'm below the x-axis, right? I'm moving I will be here, right? This will be my triangle here. So I'm looking at this length, and it's -1 over 2. Okay, so with this, indeed, symmetrical with respect to the origin. So with respect to origin. Okay, what else do I have? X-intercepts. Okay, let's look at the graph. So what I have is this, right? So I have 0, right? My first x-intercept. Then I have 1 at pi. Then I have another at 2 pi, 3 pi, etc. Right? So we can give a couple examples. So at 0, pi, 2 pi. Well, I also have it the other way, going the other way, right? So negative pi. Windy here. So negative pi, right? And going the other direction, negative 2 pi. But what we can do, right? We can write it as one expression, right? So I would write sine of 0, right? Degrees would give me an x-intercept, and then plus, right? And I will be multiplying integers, right? So you guys see 1, 2, the next one will be 3 pi, 4 pi. So k will be any integer times 180 degrees. Okay? So these are the angles for which sine is equal to 0. Okay? Maybe I will write k as an integer, right? So that fancy z means integer. This fancy letter means is a member of set of integers or belongs to. Okay, let's look at a couple other features. Maybe what do I have here? I have maximum. Alright. So maximum. Okay, so let's list couple instances when the function is at its maximum. Okay, so what do I have? So I have pi over 2. Okay, then I went 3 pi over 2 was down, so the next one will be 5 pi over 2, right? Okay, and then the next one, where is it going to be? Not 7, 9 pi over 2. Okay, so you guys see, right, so between this, right, let's look at the graph. So between this, right, and this point, I have this 2 pi, right? 2 pi or 360. So that maximum, that 1, right, the function will have that maximum every 360 degrees, right? So we can write it, how should we write it? So sine of x has maxima for, so I'm gonna have that 90, that pi over 2 or 90 degrees, plus, right, every 360, but then I still need that integer here, right? Alright, hope you understand what's going on here. Alright, let's do a couple exercises. So some practice, we'll be looking at the graph and move it. Alright. So let's figure out, let's do number 1. So use the graph. y equals sine of x for which angles sine of theta equals negative 1. Okay, that's the first one. Second one, maybe let's not do intervals. Let's do what is larger, greater. Sine of 200 or sine of 202. And that similar problem. So sine of 100 or sine of 170. They're all degrees. Okay, let's do a couple more. So number 3, which is negative, or which number is negative, and which positive, right? So I'll have sine of negative 170. Is it positive or negative? Sine of 190, positive or negative? Sine of 600, positive or negative? Sine of 240 or 250, positive or negative? And let's do one more. So for which, or find all angles between negative 500 degrees and 500, for which we kind of have done this already. Alright, and B, sine of theta equals negative 1. Okay. Yeah, so try to, or not try, just pause the video. Oh, I couldn't see. Alright, pause the video. Try to figure it out. So the practice starts here. And then come back and I'll go over it. Okay? Alright. So let's say you've done it. You have your answers. So, you know, for this question, and let's just give couple examples. Okay, we could do that, right? Something like this. But for now, it's important that you just can use the graph and know how to use it. All right. So let's look at the first problem. So find angles for which sine of theta is negative 1. Well, you just look at the graph, and the first one that comes to my mind is 3 pi over 2, right, which is 270. And we can write it as 3 pi over 2. Okay, so let's do this. And then we could also go this way, right? So here, if I keep going, that negative 1, right, which will be here, it's going to be for negative pi over 2. Okay, so it's going to be for negative pi over 2. Okay, so to find next one, we would add 2 pi to this, right? Or subtract 2 pi from this one. Okay, so we could keep going. Okay, let's look at this one. Which one is larger, 200, sine of 200, or sine of 220? Alright, so let's look at our graph. Okay, so this is 180 degrees, right? So 200 will be somewhere here, and I'm not exactly sure where. but I'm not very far from that 180, right? So if this is 200, right, this will be my value for sine, right? I don't know what it is, but I know that if I'm moving along this line to 202 degrees, the value of 202 degrees will be lower, right? So which one is larger? So this one is larger, right? And sine of 202 will be smaller. Alright, let's look at the second one. So sine of 100 and sine of 170. Alright, so sine of 100 degrees will be somewhere here, right? And 170, is it negative or positive? No, it's just positive. So sine of 100 will be somewhere here, right? It will be my value of it. And sine of 170, I'm right before 180, or right before 0. Well, so the first one, sine of 100, is larger, right? It's greater. So this is a greater number. Okay. So let's look at the second one. The third one. So we need to decide which angles here are negative and which ones are positive. So my first one is negative 170. Okay, so negative 170, so I'll be moving. We can look at the graph, or we can look at the circle, and let's look at the graph. So I'll be moving, right, this direction, negative direction, and I see that all those values of sine will be negative all the way until I get to negative 180, right? So if I'm moving here, so I'll be over there. Right? So my triangle will be somewhere here, right before negative 180. Right? So the value of sine, which is that, will be negative. Okay, so this one is negative. Sine of 190. Alright, so this time I'm moving in the positive direction. 190 will be just past 180. It's also negative. Okay, so now I have what? I have sine of 600. Okay, so if this is 600 will be somewhere here, and let's try to figure out. So if this is 360, and then 180, so this will be 540. Okay, well, if this is 540, 600 will be maybe somewhere here. I'm not sure, but I know that the value of sine will be negative. So they're all negative. How about sine of 250? Okay, sine of 250. Sine of 250, oh, it's also negative, right? So I'll keep going, right? Passing this 180, but I'm not really reaching that. So it's going to be also negative. They're all negative. Okay. Alright, let's do the last one. So I need to find all angles between negative 500 and 500. Alright, so let's look at it. Let's look at our graph. So, okay. So in the positive direction, so I'll have this, pi over 2, and I will have this. Alright, so what was that? Was that 5 pi over 2? I think so. Okay, so, or we can think in terms of degrees, I guess. So 90 degrees. This one will be 90 plus 360, 450. Okay, and that's it, going this direction. Now if you go the other direction, alright, so it's kind of gonna be, let's look at the because I don't have a graph here, right? Let's look at the circle. So I have I need to go this direction, So I have, this is 180, so negative 270 will be my first one, and I think the last, that's it. So negative 270. Okay, I think that is it. Let's look at the second part of the question. So sine of theta needs to be negative. Okay, so that's my first one here, right? So 3 pi over 2 is 270. Okay, then I'm going this direction over here. I know the first one, negative pi over 2, or negative, let's write it as negative 90. Okay, and then let me look at that circle now. So if I'm going towards negative directions, I'll have negative 90, and that's going to be negative 360 plus 90, negative 450. Alright. Okay, it's been about 20 minutes. Let's stop here.